You are welcome to Instructor Victor tutorial. This is the third edition of this class, still under the same topic, solution of a differential equation. Now, we have a problem here to solve, which is verify that x equal to c1 exponential minus t plus c2 exponential 2t is a solution to x prime prime minus x prime minus 2x equal to 0. Hence, find C1 and C2 given the initial condition x of 0 equal to 10 and x prime of 0 equal to 0. Now, I'm sure you are seeing the revelation of what I told you in the genesis of the other class. Now, I told you that whenever they give you an initial condition, that particular question or that particular solution becomes what? A particular solution. Now, watch how I'm going to solve this question and you will love it. It is very simple. Just pay attention. Now, solution to this question, don't forget to write your given. What are we giving? X prime prime minus x prime minus 2x is equal to what? 0. And we are required to show that x equal to c1 exponential minus t plus c2 exponential 2t is a solution to this, which is the given solution which we have here. Now, hence, find C1 and the C2. Now, after we are done finding this, we will now move over to finding this one. Now, we have here x prime prime. We have here x prime. We have here what? X. The x that we have here is this one. Now, how do we get our x prime and then our x prime prime? We have to differentiate. We differentiate once to get our x prime. We differentiate another one to get our x prime prime. Now, let us start differentiating. Now, when you have your x prime, when you differentiate c1 exponential minus t, what we are differentiating here is exponential minus t. The c1 here is a constant. That's what I call the arbitrary constant. It does not change. Now, exponential minus t. How do you differentiate exponential? Now, if you don't know how to differentiate exponential, it is very simple. Let's assume that you have exponential 2x. What you do is that you just have to differentiate the 2x that you have. If you differentiate the 2x that you have, you are going to have what? 2. And then that answer that you get, multiply by the exponential, by the function itself, you have exponential 2 x. As simple as that. So how do we differentiate exponential minus t? Now, differentiate minus t. If you differentiate minus t, you're going to have minus 1. Therefore, that will make here to be what? Minus. Now, minus 1 times everything that you have here, you have minus c1 exponential minus t. Now, you have plus. You have here to be c2 exponential 2t. C2 is also an arbitrary constant. Therefore, we have it to be exponential 2t. Exponential 2t, what do? You differentiate 2t, which is what you have up here. When you differentiate 2t, you're having what? 2. So let that 2 multiply everything that you have here. You have 2c2 exponential 2 t. Now, this is for the first differential or the first derivative. Now, the second derivative, which will be the last one from what we are given here. Now, we are going to differentiate from what we get or what we got from our first derivative. Now, we have here to be minus c1 exponential minus t. Now, if you differentiate exponential minus t, you're going to be having minus 1. Now, minus 1 times minus here will give you what? Plus. Therefore, this minus will cancel. And when you use that to multiply everything that you have here, you will have it come back to c1 exponential minus t plus, when you come to this place now, exponential 2t is what you are differentiating. Others are constants. Exponential 2t is equal to what? 2. When you differentiate it, 2t here, when you differentiate 2t, you're going to have what? 2. Now 2 times whatever you have here, you're going to have a 4c2 exponential 2t. As simple as that. Now, what are we required to do? We are to fix each of these what derivatives that we have here according to where they are what located. This is x prime prime, this is x prime, and this is what 2x. Therefore, we are going to embark on that journey. Now, x prime prime here, what do we have? We have a c1 exponential minus t plus 4c2 exponential 2t. You close it in a bracket. That is for x prime prime. Minus, you open another bracket. X prime is what? Minus c1 exponential minus t. Minus c1 exponential minus t. Plus 2c2 exponential 2t. This is what we have there. And then we have it to be minus 2x. So minus 2, you open a bracket, your x is what? c1 exponential minus t plus c2 exponential 2t equal to 0. Now, what are we going to do here? We have exponential minus t at this point. We have exponential minus t at this point. We have exponential minus t at this point. And if you check it, they are all carrying c1, c1, and c1. Now, what are you going to do? You factor out exponential minus t. Exponential minus t. When you factor it out, what remains here is c1. What remains here is c1. Now you come again when you have exponential minus t. Now don't forget you have minus and you have a minus. Minus times minus will give us a plus. We now have plus c1 for this. Now you now come to this other part. You have minus 2 c1 exponential minus t. So if you factor this one out, you are going to be having minus 2c1. You close your bracket. Now another one, we have exponential 2t, and then we have exponential 2t. We have exponential 2 what? T. Factor out exponential 2t, which you are not going to put your what? Your plus. Exponential 2t, you open a bracket. When you factor it out here, what is left is what? 4c2. So you write your 4c2 out. Now, when you do the same thing here, don't forget there is minus here and there is plus here. Plus times minus will give you minus. So when you factor out exponential 2t here, you are left with what? 2. 2c2. And then at this other point, you have exponential 2t. But then don't forget, you still have a minus here, which is a minus 2 times what? c2. You still have a minus 2c what? 2. All equal to 0. Please don't get confused. If you are following me, you understand what I'm doing. Now, you have here to be exponential minus t. Now, what is inside the bracket? c1 plus c1 will give us 2c1. 2c1 minus 2c1 will turn to 0. Now, plus exponential 2t. Now, what do we have here? We have here to be what? 4c2. 4c2 minus 2c2 will remain 2c what? 2. Just like saying 4 minus 2 give us what? 2. Then put that constant, which is what? c2. Now, 2c2 minus 2c2 will also turn to what? 0. Then we have equal to 0. Now, when you do this, whenever 0 multiplies a number, that particular thing turns to what? 0. And same thing here, it turns to what? 0. So 0 plus 0 is 0 equal to what? 0. This is to tell you that what? That the solution x prime prime minus x what? X prime minus 2 what? X is correct for this particular what problem. This is to show you that what this satisfies the solution of the differential equation. Now we have just done that. What are we to do again? We are hence to find C1 and C2, given the initial condition x of naught equal to 10 and x prime of naught equal to what? 0. I don't want to clean this place. I want to clean here because I'll be needing some terms to solve the what? Or to find our C1 and C2. Now, to do that, now let us observe from what we have from our first what initial condition, x of naught. At x of naught equal to 10, this should tell you that what x is equal to what 10. And then whenever you see something in a bracket, that is the what the function that x is differentiating with respect to. So x is differentiating with respect to what? To t. It's differentiating with respect to what? T. It's just like saying x of what? T. It's just like differentiating the x, the t, which is all the things we have done here. So that value that we have in a bracket is what? T. T is equal to 0. So you should be careful. Don't take x equal to what? 0 and take x equal to 10. What you have in a bracket is the what? Is the independent function. Is the independent what? Function. Now, how do you solve? You come to what? X. This is your x. You have C1 exponential minus t plus C2 exponential 2 what? T. Your x is what? 10. So write your x here as what? 10 equal to C1 exponential minus t. Our t is what? 0. So we have to put what? 0. Then plus C2 exponential 2t. Our 2t is what? 2 of what? 0. As simple as that. Now, what do we do again? 10 is equal to C1 minus 0 is still what? 0. Now, anything has to be part of 0. Don't forget that law. Before you come and think that this place now will turn to 0, it will not turn to 0. This is exponential. It is raised to what? A power. Any number or anything raised to the power of 0 will give us what? 1. So we have it to be 1 plus C2. 2 times 0 will give me what? 0. Exponential 0 will give me 1. Therefore, we have 10 equal to C1 times 1 will give us C1 plus C1 times 2 will give us what? C2. Now, let us call this equation 1 to find our C1 and C2. Now, what do we do to find our what? To look for x prime of what? 0 equal to what? 0. We have to look for another condition because we are given two conditions here. X of naught equal to 10 and x prime of naught equal to what? Naught. So permit me to write this thing somewhere so that I can clean. 10 equal to C1 plus C2. Equation 1. So let us do for x prime. X prime of naught equal to what? 0. This is to state that what? X prime is equal to 0. And then what is the independent function there is what? T. And then t is equal to what? 0. Now we'll now come down to what? X prime. X prime here is what? 0 equal to minus C1 exponential minus t. So we are going to be having minus C1 exponential minus t. Our minus t is what? 0 from what we have here. So we are done with that one. Now I have here plus 2C2 exponential 2t. Don't forget what we have here. 2C2 exponential 2 what? T, which will give us 0. Our t here will give us 0. Now you now have 0 to be equal to minus C1 exponential what? 0. Exponential minus 0 is equal to what? 1, because minus 0 is equal to what? 0. Now you have exponential 0 to give us a 1. You are left with what? Minus a c1. Then plus 2 times 0 will give us 0. Exponential 0 will give us what? 1. So 2c1, 2c2 times 1 that we have, just as we did it on the other first part, you will be left with a 2c2. We now call this our what? Equation 2. Now, what do we do, class? We will now carry this, which is our equation 1, then equal to c1 plus c2, and then 0 equal to minus c1 plus 2c what? 2. Therefore, what do we do? Now we want to look for a particular thing that we'll do so that we can eliminate one of the what? Constants. And the constant we can easily eliminate here is what? C1 and minus C what? 1. So when you add both sides, this is equation 1 and this is equation what? 2. So when you add equation 1 and what? Equation 2, you're going to have 10 plus 0 will give me what? 10, equal to C1 minus C1. C1 plus minus C1. Plus minus will give us a minus. Therefore, C1 minus C1 will give us what? 0. And then we'll be left with C2 plus 2C2. Will give us 3C what? 2. And therefore, we can deduce, or from what we are seeing, we can find out that what? Our C2 is equal to what? 10 over 3. Because you divide both sides by 3, you divide both sides by 3. 3 will what? Cancel 3. And then you're left with what? C2 equal to 10 over 3. Now, for us to find our what? Our C1, we have to substitute for the value of what? We have to substitute the value of C2 as 10 over what? 3. Either in equation 1 or equation 2. Any of them that you use, you still get the same answer. But I want to use equation 1. So we now have here to be what? 10 equal to C1 plus C2 is equal to 10 over 3. 10 over 3. So what will I do to get my C1? I have to what? Collect like terms. Therefore, C1 will be equal to 10 minus 10 over 3. And then I'm going to be having here to be what? 30 minus 10. I'm sure you're an engineering student. I don't need to show you how I did this one because you've been practicing it over and over again. So 30 minus 10 will give us 20 over 3. Therefore, our C1 is equal to 20 over what? 3. Now, we have our C2 to be 10 over 3. We have our C1 to be what? 20 over what? 3. You've gotten your what? Your C1 and C what? 2. But don't forget that this is a particular what? Solution, and it must not have any arbitrary what? Constant. It must not have any arbitrary what? Constant. Now, you go back to the equation which they gave to you. You go back to the equation which they gave to you, which is x equal to C1. Our C1 is what? 20 over 3 exponential minus t plus C2. Our C2 is what? 10 over 3 plus 10 over 3 exponential 2 what? T. So this, you may stop here as your final answer, but if you still want to bring it to its lowest term, you have it to be x equal to compare this and this. You have that 10 over 3, you open a bracket, 10 over 3 divided by this, you will be left with what? With 2. Because when you say 10 times 2 here will give us what? 20 over 3. Now, what do we have here? 22 exponential minus t plus 10 over 3 divided by 10 over 3, you have exponential 2 what? T. So this is a particular solution. I'm sure you've watched to this particular extent, and you've seen how sweet, how I like this particular subject. Please do well to like, comment, share this video to your friends, and subscribe to my YouTube channel. Thank you for watching.